0. I move 50, I divide by negative 4.9, so I have t squared equals 50 over 4.9. And I will take the square root. I will not write plus or minus. I don't know how they want the answer, but I'm just going to approximate it and put the square root. And in parentheses, you know me, I love my parentheses, divided by 4.9, close the parenthesis, and I get 3.2 approximately. So in approximately 3.2 seconds, it reaches the ground. If they want round to 2 decimal places, right? Let me see what I had. Yes, I did round to 2 decimal places. No, I didn't. So they want 2 decimal places, so please don't put that in. So put 3.19. Okay, then they want with what velocity does it strike the ground? Not a problem. In the velocity formula, I will plug in the time. So v of 3.19 will be negative 9.8 times 3.19. So times 9.8. And of course, it's negative because of the direction, 31.3 meters per second. It doesn't mean that the velocity is negative, but the direction is, because it's this. Okay, if the stone is thrown downward with a speed, so now it's not a free falling situation. It has a speed, okay? So what is your speed so I can use your speed, Brian? For part, hold on one more second. So this is part A. This is part B. This is part C, and now we want part D. What does it say for you?
So mine's 4 meters per second.
Okay, so that's V0, which is 4 meters per second. So now the velocity is V0 minus GT. So if the stone is thrown downward with the speed of this, how long does it take to reach the ground? So we want to, in this case, find the distance, because it says now it's thrown. So now I have to find S of t, which is the integral from 4 minus 9.8 t dt. So now this is 4t minus 9.8 over 2 t squared plus a constant c. But when I plug in 0, I will still get the same thing that you got 50. So this is 4t minus 4.9 t squared and plus 50. Now with this speed added on, now we want S of t to be 0. So negative 4.9 t squared plus 4t plus 50 equals 0. And we divide or multiply by negative 1. I will multiply by negative 10 actually. 49t squared minus 40t minus 500 equals 0. I'm making sure I multiplied everything. And if you ever get the chance, I'm reaching for my, because yes, you can use the quadratic formula, but again, this is the best calculator for something like this. It's T86. I don't know why, as I said, they don't produce it anymore. Order 2. 49, the first coefficient. Negative 40, the second. Negative 500, the third. Calculate, solve. It's giving me 2 solutions. T equals 3.63 seconds. And t equals negative 2.812 seconds, which is not acceptable. If you ever get the chance, I had 2, and one of them just collapsed, completely collapsed. It was not working anymore, done, dead. But if you ever get the chance to purchase, you don't have to, of course, you don't need it. This has, I think it's one of the best TI that they produced ever. Okay, or you use the quadratic formula and you get the same thing. Very good problem. Thank you so much for picking this one, okay?
Yeah, no worries. Thank you.
Because of physics, right? So they should have given the formula for a free-falling object, but they didn't, so they're assuming that we know that. No, I will not put a problem like this on the test or final exam, I promise. I'm interested in applications, of course, but the formulas will be given to you. If there is a model like this, I will give you the model. You don't have to memorize it. Oh, I used it several times and I know it, but you don't have to memorize this. Good. Next question. Very good pick. Thank you. Anything else? Okay, this was 4.9. Let's move on to the rest and do more from everything else. Do you want me to choose or?
I think it's probably best if you choose.
Okay. Do we need anything else from 4.9?
I'm good, thank you.
Okay, so let's look at 5.1. I just clicked on it to view. Oh no, I clicked on changing it. Oh, I'm sorry. Hold on one second. Okay, I clicked on view. Okay, there's 7 problems here. Okay, distances and Riemann sum. So let's choose one. They're all pretty much they're pretty much the same thing. Let's pick one and find the distance or find the area. Which one? One with a table, one with a graph.
I guess we could start with distance.
You mean the first one, number 1?
I think so.
Okay. So again, I don't know what you see, but the first one is something like this. In my example, I have 12, 24, and 1, 2, 3, 4, 1, 2, 3, 4. So 36. That's what I have. And they say use 6 rectangles. Okay, 1, 2, right, 6, 6, 6, 6, 6, 6, 6, because 36 divided by 6 between 0 and 36, the width of each rectangle would be 6. Okay, and they say using the left endpoint. So if I use the left endpoint, I have this. The left endpoint, I have this height. Left endpoint, I have this height. Left is this height. Left again is this. And left again is this. So finding the sum, the approximate area with left 6 subintervals, this will be base times height, 6 times. If it's the leftmost point, I have to find this height, this height, this height, this height, this height, and this height. So it's going to be f of 6 plus f of 12 plus f of 18 plus f of 24. Of course, I ran out of room. I'm going to erase that. Plus f of 30. And now we have to approximate those values. From my graph, again, I don't know what you see, but from my graph, f of 6 is f of 0. I'm sorry, f of 0. F of 0, f of 6. F of 0 has to be inserted here, plus f of 0 plus f of 6. 0, 6, 12, 18, 20, and 30. I forgot to write f of 0. 0, 6, 12, 18, 24, and 30. Not this one, because we are using the leftmost point. It will be an overestimate, obviously. So f of 0, in my case, is, if that's 12 and that's 24, so 1 unit is, yes, the same thing, 6 and 6. Okay, so 1 unit is 3. So 27 plus f of 6. F of 6 is roughly, for me, do you see the same thing with 24 here? Somewhere here? Do you see the same thing? And then 12?
No, mine are 4 8s, but it's still.
So after I determine this height, and for my graph is 27, now I have to approximate this, which is not easy, because the unit for me is 3. So I'm going to subtract 1. So I'm going to say that f of 6 is 26 plus f of 12 for me is roughly 25. Difficult to approximate. Now f of 18 for me is about 21, roughly. This was 18, so 21, roughly, yeah. F of 24 is exactly 18 for me. And the last one, f of 30, is 12 for me. Of course, I have doubts that this will be exact, right? So I just have to add them up and then multiply by 6. I rounded grossly. So 27, 26, 25, 21, 18, and 12. And I multiply by 6. And I got roughly 774. It should have a range in which it accepts the solution, the answer. Then the sample points are right endpoints. So for such a function that is decreasing, we still have 6 subintervals. 6, 1, 2, 3, 4, 5, 6. Then for the rightmost point, it will be this. So now we will be using this height. For the next subinterval, I will be using this height. So this is one area. This is the second one. This is the third. This is the fourth. This is the fifth. And now this height, and this height, and this will be 0, because the height here is 0. 1, 2, 3, 4, 5, but 0 here. So the area right 6 will be still base times height. So if this is 0, 6, and 12, and 18, and 24, and 30, and 36, I will have f of 6 plus f of 12 plus f of 18 plus f of 24 plus f of 30 and plus 0, but let me write it because that's 0. And you estimate all these and multiply by 6. And then the midpoint. For the midpoint, you have to estimate the height here, and here, and here, 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 and here. And determine this height, determine this height, determine this height. Difficult, because it's difficult to estimate those numbers. So the first one was an overestimate. The second one will be an underestimate for a function that is decreasing. So this is an overestimate. The second one will be an underestimate. And the best will be the midpoint, using the midpoint. Which of the numbers gives the best estimate is the midpoint. Okay, let's see what else you'd like to see from this so we can make progress. These are all pretty much the same. Would you like to move on to section 5.2 and then we can come back? I just want you to have an idea about each and every section.
Yeah, that's fine. They all do look pretty similar.
Yes, so let's look at 5.2. I want us to touch up on a little bit of each section so you can make progress. Okay. It's all about the limit of the Riemann sum, and they want an approximation. Okay, let's look at problem 4. Is that okay? Can anyone give me your problem 4? Because I see one here, but I'd like to use one of yours. Any?
Is it a midpoint rule for problem number
Yes,
4?
number 4. Yeah.
So it's the upper limit of 96 and the lower limit is 0. And sine inside the parentheses is square root x. And then dx. And n equals 4.
Perfect. So there is no antiderivative that we can determine. We cannot find a function whose derivative is that. Not by hand. So what we're asked now, we're asked to approximate. It says, use the midpoint rule with a given value of n to approximate the integral. Fine. So I want between 0 and 96. This is my prep. I want 4 subintervals. So then I need to determine delta x, delta x, delta x, and delta x. So when I divide 96 by 2, I get 48. When I divide 48 by 2, I get 24. And when I add 48 to 24, I get, what do I get? 72. Yes. So, and all these are 24, 24, 24, and 24. We're asked to use the midpoint. The midpoint will be 12. The midpoint will be 24 plus 12. The midpoint will be 48 plus 12. The midpoint will be 72 plus 12. The midpoint, 84. So then, in order to approximate the integral from 0 to 96, from sine the square root of x dx, because I cannot determine this exactly, I'm going to say delta x, which I know is 24, delta x is 96 minus 0 over 4. 96 minus 0 over 4, and that is 24. Multiplied by base 24 times the height, f of 12, plus base times height, so that is times f plus f of 36, plus f of 60, plus f of 84. Okay, so I don't know how you would like to do this, but what I like to do, I create a table, a list, in which I put 12, 36, 60, and 84. 12, oops, not there, here, 12, 36, 60, and 84. Then I go back to list L2 at the very top, and I put 24 multiplied by sine of the square root, but inside the square root I'm going to put list L1. And now when I press enter, I get all these numbers. This times this, this times this, this times this, this times that. Assuming that I checked that it's in radians. Yes, it is. And now all I want to go to stat and calculate one variable stats for list L2. And I calculate, and I get the sum to be 15.7. How many decimal digits they want? 4 decimal places. Interesting. So we found that that is 15.708 is 487. So although we're not able to find the exact area between under the graph of this function between 0 and 96, we were not able to find the antiderivative. We could not determine it exactly. We were able to determine an approximate